Hey guys, it's Mr. Ivan here. Today we are gonna go over volume, specifically because there's a few students today. I won't mention any names that scored 70% on Mr. Goodrich's test. A lot of the questions were volume and slope. It's a bit unfortunate, but it happens, guys. All that matters is how we bounce back. So hopefully the next time this comes around, we'll be prepared. Um, I mentioned right here, volume can be tricky. It really is. All right. There shouldn't be any reason to think you just can't get it. But the reality of it is, it's just something called plug and chug problems, which means you take a formula and you plug something into it. Okay. I mentioned that right there. This is just referring to problem where formula and numbers is all you need. So we should be familiar with area. This is just the very next step to it. So we're going to cover the shapes we see first. All right. The very first thing is a cube. All side lengths are the same length for a cube. Okay, so height, width, and length are the same. I highlight them, but it should be pretty obvious that a cube has four identical sides, so it's just the same thing. All right. A triangular prism is obviously a triangle in the three-dimensional aspect. You notice the height is always from the base of the triangle to the very top. The length of it is how long the prism is, and the base I just mentioned is highlighted red. And it would technically not be wrong to say width, but if you remember, the area formula for a triangle is base times height, right? Or it's 1/2 base times height, I believe. So we use base when we're for the triangles. Next, we have a cylinder. So same thing here. A cylinder can be laying flat and it can be standing up. So what I mean by that is just think of a soda can, right? If a soda can is standing up, you're referring to it in height. If it's laying down, you're looking at how long it is. So that's length. So once again, I have all the key measurements here highlighted and color coded. We have radius, diameter, and length. Or if the cylinder is standing up, it's radius, width, and height. They might still even say diameter, like I said. And note it right here, length can also be height, and problems can give you radius, width, or diameter. With the diameter, that's the very same thing here. It's just different ways to say it. Next is a sphere. Honestly, I'm not drawing a third dimensional sphere. I have no idea how to do that. All you need for the volume of a sphere is the radius or the diameter, right? But you guys should remember the diameter. That radius is the diameter divided by 2. So next is cones. And this looks like a lot, but if you notice, it's just the same thing in 3 different ways, right? Radius and height, or diameter and length, or height. Length and height are interchangeable here. The reason it looks like a lot is because it's just different ways it can be presented to you. The first one is like an ice cream cone. The second one is like a teepee. And the third one is just an ice cream cone again with different variables. Then we have a rectangular prism, right? Rectangular prism has height, width, and length. This is the most basic it gets in terms of volume outside of a cube. So I mentioned here, it looks like a cube, but it's not because not all the sides are the same. So it's a rectangular prism. This is just about every 3D shape you'll see in middle school, and honestly, maybe even for high school. You might get some weird ones later on, like parallelograms and all that, but I mean, hopefully your teachers are good eventually. If not, then I mean, just look it up. So, from everything I just said, the main takeaway is you should learn how to identify the shape and the width, height, length, radius, and diameter, as they aren't always given. Okay, and let's make one thing clear: if you're looking at a square, you're not gonna have a radius or diameter. All right, don't think that every single shape has all these variables. I'm just covering all the bases at once. So, we're gonna recall our knowledge of area, which I'm gonna summarize very quickly. Okay, the area of shapes of a square is height times width. Okay, and obviously it's a square, so height times width is the same number. Another way to write this is a squared. Okay, um, what I mean by a is you're assigning the side length to be a, you're squaring it because it's the same. On the left we have a triangle, and you have to remember the formula of a triangle is always on a right triangle. Okay, I don't believe you guys know how to get the area of a triangle that is not a right triangle. So my drawing on the right is technically wrong. Okay, but just imagine it's a right triangle. The area is base times height divided by 2. That is the same thing as 1/2 base times height. Okay, I just think this one is a lot easier to plug into. Circle is the radius or diameter, and you plug that into the area is equal to pi times r squared. You should always assume 3.14 if you're not given a calculator. Okay, if you're given a calculator, just put the little pi symbol in it. If not, then 3.14. Your answer is only going to be off by like 0.01, 0.03 maybe. It's nothing crazy. R squared is just the radius times itself, right? If you're given diameter, just divide it by 2 and you get your radius. A rectangle gives you width and height, and the area is just height times width. Okay, so it's the same thing as a cube, but these numbers are going to be different. And then I really recommend you learn these. Okay, I know it might pain you guys to go home and do schoolwork, but the reality is you can only you're only gonna get scores that reflect how much effort you put into it. Okay, and yes, some of you guys honestly just pick it up instantly in class. That's perfectly okay, but it's still a good habit to study, because one day you might get to a class where it's not just common sense to you and you start struggling more than someone who's used to studying. Okay, I would just do flashcards, write formula of blank on one and then write it on the back, and that's how you would get these down. Okay, and I'm recording this video after you guys took your test, so I can very much tell you that I saw the question that wanted you to find the surface area. Mr. Goodrich did not give you guys the surface area formula specifically. He gave you a hint that would make you know the surface area, but you needed to know the area formulas. They were not given. So, if you think I'm spouting nonsense, you probably got that question wrong. And then why did I review area? Well, volume is just the area of our shape times length. Obviously, this does not apply to spheres and cones because they don't really have lengths, okay? And all I mean by that is that volume takes the area formula, adds something to it, and that's volume. That's also why, if you notice, the units for volume are always cubed and the units for area are squared, okay? It's because you take the square and then you multiply it one more time by something and that gives you the cube. So it's just all that saying is the same thing I just said, right? Most of these volume formulas are making you find the area and then multiplying it by its length. Look at an example of what I mean by that if you guys are still slightly confused. Look at this rectangular prism, right? You guys should be able to identify that. That's a big thing. This is actually the same shape that test wanted you to find the surface area for. So I know that area is height times width, okay, for a rectangle. So I find that my area is 35 inches. 7 times 5 is 35. And obviously, really, really important, it is squared. But we're looking for volume. So if you look here, the volume is equal to the area times the length. The area was 35 inches squared times 10. This should be 10 inches. The volume is equal to 350 inches cubed. That's it. Okay. Like I said, note that my units are cubed. This is always the case with volume. Whatever unit you're using is cubed. Okay. Doesn't matter if you're in feet, inches, yards, whatever. It's always cubed in volume. And if you look here, this is just another way to write the volume of a. This is another way to look at the formula. Okay. If this is all confusing, just ignore it and remember the set formulas that I'm gonna give you guys. Okay. We're gonna go a bit more into depth here, right? The volume, as I mentioned before, is the area of our shape times length. So that's a very general way to look at it, because length is interchangeable with height, and you're not always given a variable that says L is this. Okay. I mentioned this earlier with the soda can example, right? You can have length or you can have height. They're basically the same exact thing. It just might be given differently in the context of a problem. So how does this volume thing apply across our 3D shapes, right? So we look at our 3D shape here. We have a cube. We identify what the 2D shape is, and we look at that area formula. So I'm gonna use the triangular prism. Okay. So let's look at this right here. So I know that the triangle, and I know the area formula for a triangle is base times height divided by 2. All right. You identify the 2D shape. That's what I mean by I know the triangle. And when we go down here, look at this. The area, oh, you can't see that anymore. Base times height times 2 of a regular triangle. And I'm just multiplying it by the new length. Okay. And that gives me the volume, right? So that's how you can break down the volume formula to understand what's really going on. The same thing goes for this cylinder. The volume of a cylinder is basically the volume, the area of a circle, right? Because you notice it has a circle up here, times the height. And that gives you the volume, right? The height is the new variable. That's really all there is to it to explain this conceptually. Like I said, if none of that makes sense to you, that's okay, right? You don't even need to know any of that. It's just to understand what's going up. And I just mentioned, if none of that made sense to you, just focus on this, okay? These are your formulas, right? I've written them here. Telling you what the shape is, what the figure is. So if you look here, I'm using the A example. I'm not using height times width because I'm giving you guys the actual formula that is always plugged into it, okay? I'm not going to give you guys height times width times length and say they should all be the same because that's not the volume formula. Like, that's universal, I guess. So the volume is the area to the third. So if the side of the cube is 2 inches, it's 2 times 2 times 2. That should be 8 inches cubed. Okay, that would be your volume. Rectangular prism is length times width times height. You just plug those in. You will always be given these volumes. Well, I would hope so, but right, you just plug them in. Next, we have a cone. Okay, and here's another thing. This formula can also be 1/3 times pi r squared times h. Okay, I personally think it's a little bit confusing when it's written like that. So I do pi times r squared times h all over 3. Okay, remember PEMDAS? There's a parentheses there. Okay, so if you were given r and h, you need to first square r, multiply that by h, multiply that by pi, and then you divide by 3. If you plug this into a calculator, you need to really be careful because if you forget your parentheses, if you divide wrong, you're gonna get the wrong answer. Okay, and that probably honestly happened on that test today if you were using the calculator. Okay, a calculator always follows PEMDAS, so you need to know how to make sure that's correct. The cylinder is just pi times r squared times h. That's it. It's not divided by anything else. All right, pretty simple. And then obviously, if you're given the diameter instead of r, just divide it by 2 to get r. That's all I'm saying here. It's just a little note. And we have a sphere. Okay, a sphere is 4. It's always 4. Okay, this is a formula. It doesn't change. Times pi times r squared over 3. Okay, it's all of this is done first. Okay, so if you're gonna approach this problem in a calculator, first I would square r. Okay, so we're gonna say that r is 2. I now know that r squared is 4. So when I put this in the calculator, I can do 4 times pi times 4, and then that's all of these done. And then I divide whatever that final answer was by 3. Okay, so that's how I would approach that, and that's what I was implying earlier by plugging this into a calculator correctly. A hemisphere is 2 instead of 4. If you notice, that makes sense because it's only half of a circle. Okay, don't really worry about this. I really don't. You'll see it. It might show up in certain challenging problems, but they're challenge problems for a reason. Here is a pyramid. Okay, this one can be a bit tricky because if you notice, I have it written as the area of a base. And the reason for that is the area of a base could be any shape, right? You can have a rectangular base, a square base, and well, I guess I technically just lied. It can be rectangular, squared, or sometimes it can be like a pentagon, right? Um, Most of the time it's just gonna be rectangular or squared. So if you had a squared base, you would use a cubed, right? That's what you would use for the area of base. If you had a rectangular prism, you would use the area of a rectangle. Okay. So if that is confusing, sorry, I didn't really think about how to explain that before I started recording. Yeah. So all I'm saying is that this base right here can be a square or a rectangle, and depending on that, that changes what you plug into the formula, right? So if it was a square, you use height times width, or a squared, and if it's a rectangle, you use height times width. Let me. And we have a triangular prism. Okay, the difference between a triangular prism and a pyramid is that this one always has the rectangular base down here, and then it's, uh, you know, triangles on the other side. The formula for this one is height times base divided by 2, and then once you get that answer, you multiply it by your length. You just plug these in, and you always follow PEMDAS, okay? You guys don't realize how important that is, because if you do height times base times length, and then divide that by 2, you're gonna get a completely different answer. And honestly, the best advice I could give you is just practice and apply these formulas, and you'll do just fine, okay? I highlight that these are the hardest ones to know. I really wouldn't bother with them, okay? I don't think you should know. I don't think you'll ever have to memorize these, okay? Um, Obviously, basic area formulas, yeah, they're pretty easy to memorize. And honestly, I would just recommend you memorize these too. You never know. Teachers are very different. And then if you go on to college, professors are very different. And then even if you're one of those people that says, well, I'm not going to college. If you go into a trade, guess what? It's called trade school for a reason. You still have to remember things. You, it's always, learning is always going to be no matter what profession you go. So you might as well start now. Even if you're not going to trade school and you're not going to college and you go to the military, well, guess what? Militaries have specialties and you need to know things. Okay. You guys don't believe that? Just ask anybody who has served. Um, my friend is in air traffic controller. Air, yeah, well, he sits in the ATC tower. I'm not sure what his actual role is, but he has to study. Okay. Not like it's just, oh, I didn't go to college, I didn't go to trade school, I can never learn anything. That's just not how it works. All right. And down here, I have the practice set. Like I said, I'll do these in a separate video to keep this one short. If anything, this challenge problem down here. Oh, sorry, I need to add a page. If you guys aren't in Avid, I would kind of ignore this. Well, I would try it honestly if you think you're able to solve this. I already have the video out for that, but these challenge problems are mainly for the Avid students who want to use them on the tutorial, because it's meant to be a lot harder than these. Okay. So like if you're an Avid and you understand this is meant to challenge you. If you're not an Avid, go feel free to do it. If you can answer this, then I would bet you're pretty good with volume, and you'll be ready for the next test. Okay. And once again, like always, if you are an Avid, please remember to write your name in pen, use a Foursquare, and it's not a requirement, but please put your notes ready to be graded. All right. I'm not you. I can't sort through your entire notebook and know exactly what you're trying to have me grade. And honestly, some of you guys are not very organized in the nicest way possible. So when I'm looking at your notes, I don't see any. And then you guys walk over and then look at me like I'm dumb because I couldn't find the page that stuck to this one specific page. 40 pages in, it's a hassle. So please just keep that in mind. I think that's about it. Like I said, I hope on the next test we do better. Hopefully the student who is the reason I'm pushing this video is watching this. And I wish you guys the best of luck.